Hello, everyone. Hello, Rennie, Jason, everyone. Good afternoon. Good evening. Welcome. Listen. So yesterday we had a wonderful time. I did not check very carefully about the exam, and I received couple of emails, not a couple, probably 10 plus emails, and they tell me there is a bug in the Google form. I will check it. Okay, I will check it. I was planning to analyze the results and send it to the class, but you know what? They have many students. So many students did not take exam because they are traveling, they are in the camp, and they said, "Can you give us a couple more days to complete the exam?" I said, "Sure. Why not? Let's do that." Okay. Yeah. So class, I want you to know, I did not forget you. I did not. Okay. Right. So what I'm planning to do, I said, Saturday is the last day. You are going to take it. And I will look at this weekend. On Sunday, we have office hour. I'm going to discuss last week homework, today's homework, and exam. We are going to do very detailed, question by question. Can we do that? Sophia? Can we do that? Yes, I'm going to do the question by question. We are going to discuss. Yeah. So if you cannot come to the class, get an email. Okay. So I know some of you, I know Rennie and Jason are going to China soon. Right. They're going to leave in China soon. I know that some in the China may have come to the class, may cannot. It depends if you are traveling. If there's no internet, so you cannot come to class. Recording is available, as you may recognize, started last week. I did not wait. You send me email, get a recording. After the class, I send out the recording right to the class. Why? Because there's so many students are traveling, okay? Right? Are traveling in the camp. Now I just, oh, you're already in the airport. See, Jason already in the airport. Jason in the airport, come to the class. Thank you. This is amazing. Right, we are going to do a quiz exam. We are going to discuss during the office hour this Sunday. Yeah, if you miss it, I will send an email. Okay. Yes. You do not need to send an email. I will send it to you. I'm planning this week, today, next week. I will send after class. I will send automatically recording to everyone. Now, then following week, probably we are not going to send out. Okay, yeah, that's one. The second one, in this point, as you know, class already in the college level. Class already in the college level. Hard? Yes, surely. Can we do that? Absolutely. Not because class challenge, we cannot do that. We are learning classes step by step. You are not just jump to the class today, or it's so hard. We learn from very basic, from the measurement, from the significant figure, from the SI unit, from the chemical change, physical change, chemical property, physical property, periodic table, element, compound, the fundamental law, the structure of atom. Right? Now we learn what? We learn electromagnetic radiation. Right? We learn the quanta. We learn the photon electron effect. We learned light have a duality property. You have a wave, you have particle. So that's what we have. See, it's hard, absolutely. Can you do that? Absolutely. Every year in this time, and the students said, "Oh, I love the material. And I sometimes ask why you love the material. It's very challenging. Oh, challenge, you love it? Yeah, we are going to learn more. Right? So every year this time seems very challenging, but and students doing very well. Keep doing, keep learning. Right? You are smart. You are very smart. You feel very proud of yourself in very young age, systematically and thoroughly learn chemistry in the college level. You got it, Eric, right? So in next year this time, we almost going to take an exam. Yeah, next year this time we have called JPH Junior Chemistry Competition. So this year will be June 20. Let me check. Okay, let me check. Give me a minute. Okay, it's on Sunday, June 9. June 9. Let me check this year. June 9, 26. June 9, 26. We have called JPH Junior Chemistry Competition. Next year, which day? Let me tell you which day. Okay, I can tell you now. June 9, 25th. You are going to participate the JPH Chemistry Junior Level Competition. So that competition will cover chapter 1 to chapter 9. Now, rest of the chapters, we are going to do all the way go to the February. Now, after February, what are going to do? You are going to take an Olympia exam, USNC Olympia exam. You have so many competitions, such as MIT Harvard, such as Berkeley, BCT, such as WCT, Washington University in St. Louis competition. There's so many opportunities. Some of you will do Science Olympia, Science Ball, middle school group, high school group. Lots of opportunities. So, but remember, everything is from today. Let's do week by week, month by month. Always remember in the class, make good notes. Make very good notes. You have a question, text here. I will help you. Bring your question to the office hour. And after the class, review it. Then you do your homework. You do your homework. You got it? Now you come to the office hour. You remember, JPH, 100% always here to help you. You are not alone. You know what's mean alone, right? Yeah, so not a home alone. I'm always here with you, help you. That's the way it is, right? So I will never throw my students to the ocean. I will say, oh, yeah. You are going to swim by yourself. No. I will let you swim in the ocean. I always side by side with you. Learning is the same. Learning is the same, God, but you work hard, work smart. Work hard, work smart. Okay, now class, I promise you, will be a little bit challenge, okay? Will be a little challenge. But it's you will be okay. Review. So what we did? We know the first class we said electromagnetic radiation. Light is a wave of property. You have a wave of property, such as you have wavelengths, you have a frequency, you have a speed of the light, you have energy, you have a diffraction. Right? You have amplitude. Have a nice trip. Have a nice trip, okay? Yeah, have a nice trip. Yeah, bye. So this, do you think he is so devoting, so dedicated? In the last minute before go to the airplane, come to the class. What do you think? Of course, that's a good one. That's a really good one. Yeah. So wave You have a wavelength, you have a frequency, you have a speed of the light, you have energy, you have a diffraction. Diffraction. Did you remember? I'm here, I'm in my office, and the people, even in the backyard, can hear me. Okay, can hear me. Why? Because sound wave can be diffracted. That's a wave, not all course. And later on, we introduce you have a particle property too. Blackboard radiation. Blackboard radiation. Did you remember? Blackboard radiation. So you have a particle property. You have a particle property. What means particle property? Which means you have a mass, you have a velocity. So that the P equal m times v, and that's called linear momentum. Linear momentum, right? It's a linear momentum. You got it? So the electromagnetic radiation, light have a duality, double. You have wave and a particle. Wave and a particle. So I'm review here. Okay, right? So if you reviewed at home, you understand what's mean, okay? Now, not only that, so we said electromagnetic radiation, you have a duality property. We said electromagnetic radiation. However, we can expand. We can say matter. All matter has duality. Matter, including you and me, school bus, car, bike. All matter has wave and the particle property. Next, wow, I get very confused. Let's look at. Okay? Right, let's do some practice. Remember, the class, we're getting a little bit challenging now, but once we go through this couple of classes too, and the class will become much easier, okay? Yeah, you get used to it. Now, let's look at, okay? So can we go to sample 1? May I give you 2 minutes? 2 minutes. You try your best. Try it, okay? 2 minutes. Yeah, you have answer. Send it to me. Yeah, you have answer. Send it to me. Okay, thank you. Good job. Good job. Yeah, 1 more minute. Try. Make a good notes. Try your best. And we are going to discuss in a minute. Good job. Thank you. Katie, thank you. Good job. Yes, all light have the same. Now here is not this is not a photon. This is a proton. Photon is different. Adi, right? Proton. We learn proton second chapter, right? Chapter 2. Yeah. Photon has the same speed. Okay, I'm going to do that. Okay. Now, when you see question like this, where will we get started? This question. Make a note. Where we get started this question, right? A question like this. How can we get started? Now, read the question. Estimate the wavelength. Estimate the wavelength. Right? And that wavelength is what? Is a proton. Where is a proton? Did you remember we learned chapter 2? Right? Rutherford nuclear model. The proton in the nuclear. Proton, neutron in the nuclear. That's one. Where is the proton? Within an atom in the nuclear. You want the proton, this one, what's the wavelength? And the moving speed, 1/100 speed of the light. And we know the light, right? We know the light. And the light speed is a 2.9979 times 8 meters second. So in this case, what do we know? We know the light, we know the speed, we know the mass. We need to calculate the wavelength. This question is related matter wave, matter duality. It's a matter duality. Here is a proton. Not only electromagnetic radiation, we said, if electromagnetic radiation is what? It's lambda equal h divided p. What's the p? Linear momentum. H is a constant. P is mv. And we just reviewed, not only electromagnetic radiation has a wave, matter has a wave. Here it's what? This is the proton. Proton also has a wave. Now, then you just put the number. H66206 34 Joule second. And the mass 1.673 times 27 kilogram. And the speed is 1/100, 2.9979 times 10⁸ meters second. As you know that, I'm going to erase this one. Joule, 1 joule we learned in the first class. That is SI unit. 1 joule equal 1 kilogram meter square second square. Now I'm going to use this unit, which is a kilogram meter square second square. Before you do the calculation, I want you take care the units first. Second. You do the elimination, right? Kilogram, meter, so that you get a meter. Wavelength indeed is a meter. Wavelength indeed is a meter. Okay, right? Wavelength is a meter. Okay, you got it. Now you do the math. How many significant figures we can use? And here it's very hard because there is no measurement. Do you see? Now, significant figure determined by the measurement, but Since the next question, you have 5.00 gram. That's a 3 significant figure. So then in this one, we also keep 3 significant figure. Now, there's no reason. Based question A. Why? Because there's no measurement. However, the second question, B, you have a 3 significant figure. Now, here, I'm going to keep a 3 significant figure. Got it? So which you calculate, it's 1.32 times 10 minus 13 meter. Now, we are not stopped here. Why? As we discussed in the first class, chapter 3, the size of the atom. Look at it here, because the proton or protons are inside of the nucleus. And now we wanted to compare with the size of atom, which unit is a PM, picometer. So we are going to convert it to the picometer. Right? So you got what? You got a 0.132 PM, picometer. As you know, the average size of atom, average atomic size, it is 200 PM. I want you to remember this one. In the future, you are going to use it. Now, I want to ask you, running average atomic size is 200 PM. Now, his wavelength is 0.132 PM. Big or small? It is compatible. It is compatible. It's not that small. It is not that small. See, it's the same level, right? So you have a PM, 200 PM. Now you have it's about 0.1 PM. It's very compatible. Very compatible, which means indeed proton in the nucleus has the wave property. Now, then go to next one. That's the A. Now let's go to the B. The same B is what? It's marble. Tell me, William, marble, what do you think before with the calculation? Do you think wavelength big or small? Should it be extremely small? Eric, agree with me? Should it be extremely small? Why? Marble, you know the marble, right? Everyone knows the marble. I threw marble when I was very young. Why? People play around, throw the marble, go to the pond, see how much it can go. Now let's do that. Lambda equal H MV 626 times 34 kilogram meter square S square S. Right? Now go to next one. It's what? It's a mass 5.00 gram times kilogram 1,000 gram. You convert it to SI unit, right? And then speed 1.00 m second. Do the math. Cancel this one, cancel this one, cancel this one, cancel this one. You get the meter. And that meter, if you do that, it is 1.33 times 10 minus 31. Class, I want you compare the wavelength gram here, you cancel it, see. The wavelength is minus 33. The marble, that's the marble. you compare the size of the marble with the wavelength, big or small. Can I say extremely small? Can I say Dylan said very, very, very small? Right? Extremely small. You compare, see, 10 to minus 31 to the size of the marble. What's it mean? Which means marble most has the particle property, not the wave, because the wavelengths we cannot detect. On the other hand, the wavelength proton within atom is a 0.132. Here it's a 200. It's not that small. Tell us indeed proton in the nuclear has a wave property. Class, you understand? Please remember, we are learning science. When you do the science, the calculation, the number, we need to understand what's mean. What do we learn? From this experiment, this example, tell us proton has a wave property because that wavelength compared to the size of the atom is not that small, compatible. However, the wavelength of marble is extremely small. Okay, now look at it. So each class after we did the conclusion, what's the conclusion? As expected, wavelength marble undetectably small. Can you detect 10 to minus 31? Probably not. However, the wavelength rapidly moving proton, not a photon. Remember, this is the proton. It's not very much small compared to the size of the atom. 200 pm, which tell us proton has a wave property. Marble is the particle property dominated. Now, as you know, each section, we have what? We have a summary. Now, we have two more practice. Now, before we practice that two, let's look at electron and the matter has a both wave-like particle-like property. The large piece matter, what's mean large piece? Which means high mass. Large piece, see, the large piece matter, which means the mass is big. Like marble, 5.00 grams. The most is what? It's a particle property. Particle property, which means it's mass and the velocity, m mass, v velocity. The very smaller beta matter like proton, you have a wave like a property we just discussed, which is lambda, wave, frequency, wave, piece of matter in the intermediate mass, like electron. Well, of course, this chapter mostly about related to electron. You have a particle and a wave property. I'm going to repeat. You, me, school bus. Although we call it matter wave. However, because our mass, most we are the particle. However, if the matter is very small, and that one you will have a wave property. But matter between, you will have a particle and a wave. Let's do two more examples. Okay, two more. Then go to sample 2. I give you 3 minutes. I want everyone try it. Okay, everyone try it. Do that. Thank you. Good job. Good job. No, I'm going to do that, okay? I'm going to do that, okay? Adam, okay? Yeah. So again, read the question. What the question about? See, again, so this time it's not estimate. You are going to do the calculation. Now this time it's the electron. It is the electron. You know the wavelength. Remember electron in the atom. All matter has an electron, right? So that's the calculate. H. I need to slow down a little bit. Handwriting is terrible. Okay, feel sorry. H M V 6.626 34 kilogram meter square S square S. Oh, by the way, class, your homework is outstanding. Why outstanding? Almost everyone. Very detailed, logical thinking step by step. This is the first group. Homework like this. I hope you will continue keep this way. Yeah. As we said, we are learning. We are to learn how to logical thinking, okay, critical thinking, right? This group is the first group, group 2025. 2 questions. We repeat 3 weeks. Why? I ask you have to do this way. You need draw the graphing. Base the graphing. You calculate the slope. Then you slope to do the calculation. And probably these kids, older than you guys, very good to use calculator. So do not want to do the graphing. So just use calculator, give me number. And I said, no, I sign again. Last week before, I sign again. Last week, I sign again. Did 3 times, even 3 times. Still have 3 students. Did not follow my instruction. I talked to them on the phone. I'm very serious. I'm very serious teacher. Let me tell you, right? Because I care about all, not only one. All. That's very good. Now that's good. Math. Here's a math. 9.109 times 10 to 31 kilogram. Now, 1,000. 1/1000. You times 2.998 times the 8th meter second. How can you do that? You are going to cancel your unit. the kilogram. And here is a meter square, here is a meter. Now you get a meter. Right? You get a meter, okay? You got it. So now listen, Nicole, it seems will take a couple more minutes, even maybe 2 minutes. But if you do this way, that will benefit your life. In your life, you will say, wow, it's the best way. You will go to the high school, you go to college. I did the same. Do you think naturally I do this way? No, because my teacher teach me this way. And as you know that, wavelength is what? It's a meter. So which means that's right. The formula is right. The units is right. Then you just be careful, do the calculation. Right? Do the calculation. So in this case, how many significant we can use? You know, we can use 4, we can use 3, because all this one is not a measurement. Got it, right? Yeah, I normally use 2.9979 times minus 8 meters second. But here to give to us, so you use 4, right? You see, normally I use this one. Normally I use this number, okay? Of course, someone use this one, 3.00. You look at some work, so use this one. That's okay too. That's okay too. Yeah. Now you do that. I do the calculation. Can you tell me the wavelength big or small? Educated, yes. It is small. It is small. But that is small compared to the size of atom. It's not that small. Make sense? Okay. So you get what? You get a 2.43 times -9, or you get 2.43 nanometer. Can you tell me what this belong to? Electromagnetic radiation. What's this? 2.43 belong to what type of electromagnetic radiation? CC? Very good. It's UV, right? Ultraviolet. Ultraviolet. Can you see that? No. This is probably more than ultraviolet. Let's go back. Let's go back, okay? Let's go back, okay? Let's go back. Give me a minute, okay? So that's our notes, right? You can always go back to check. Okay, where we are. Where we are, here. Here. And that one. So here what? Lambda meter. And that meter is what? -9 is here. It is here, ultraviolet. You are so good. You are so good. You are so good. It's this range. It's this range. And the size between the atom is here. Atom is -10, right? It's just within the atom. See, atom is with the virus in this range, 10 to the -9. You got it? So this is a very, very important reference. Right? Very important reference. See, basically it's here in this range. And the electron, where is the electron? Electron with the atom. Right? So it's very small, but compare the size of the atom, it's not that small. Because the size is what? It's the size of atom, right? You got it? Cool. So which means electron is a wave or particle? Oh, you do not have this document? Send me email, my friend. Not the particle, it's wave. Because the wave is not that small. The wavelength is compatible, which is a wave. Got it? It's a wave. Electron with an atom has a wave property. Remember, we are going to learn that in a minute. Wave property. Electron within an atom has a wave property. Wave. It's wave poverty. Now, some of you do not have class notes, send me. Oh, yeah, white black. No, my friend, ask your daddy use a color printer. See, you have color. You have color. The notes has a color. Yeah, ask your daddy use a color printer. See, you do have a color. There's 4 different colors. See, 1, 2, 3, 4. Anyway, we need to move on. Okay. We need to move on. See, this is what? This is red. This is yellowish. This is firework. All different color. You have a color. See, move on. Oh, no, we are not here. We are not here. We're almost here. Yeah, we are here. Now, sample 3. Can you tell me this rubber bullet, 5 gram, wave or particle? Wave or particle? And that should be particle. That should be particle. Now, let's calculate. Zoe, now do calculation, please. Zoe, do the calculation. Okay, I give you 2 minutes. 2 minutes, okay? 2 minutes. Everyone can do that. Thank you. Thank you. Good job. See how good you are, Katie. It's very good. Look at Sophie. Sophia, good job. Good job. Yeah, very good. Put a unit. Put a unit. Pay a significant figure. Okay. Very good. Very good. Okay. Yeah. Okay. I'm going to do that. Class is doing very well. Right? So let's look at. So we calculate the rifle bullet, 5 grams, 5.0 grams, which means I can say before I do the calculation, that should be particle. The wavelength should be very small, undetectable. Let's calculate. Lambda equal H mv. Matter duality and 6.626 times 34 kilogram m square s square s. Now the mass is 5.0 grams. We need to convert it to the SI unit. So which is a kilogram, 1,000 gram, then the twice of the speed limit, 2 times 331 meter second. Right? Now you do the math, cancel. Now that's one significant figure. Some, like in this case, you can keep 4 significant figure, that's fine. Because in this case, all this one is a constant, this one constant, you can keep it. So this barely has a measurement, okay? But here, it exactly tell us the measurement, right? So we got what? I do the math, I did it for you, okay? I did 2.0 times 34 meter. And that one we cannot measure it. This is too small. Too small. This is very too small. Now, definitely, here is a summary. Electron matter. Why we emphasize electron? Because this chapter we are discussing electron. The second chapter, we discuss the structure of atom. We discuss electrons, neutron, proton. And this one, we all discuss electrons. That's why we emphasize electron. Electron and matter has a wave-like particle-like property. Large piece is a particle, like here, this one. Smaller piece, it is a wave. It's a wave. And between the wave and the particle. Between you have wave and the particle, okay? Can we move on? So this is the one. Hard is hard. But when you do the homework, how did you get this one? Oh, my friend, that one is to the math, okay? So for example, minus 34 is minus 34, right? That one is a Planck constant. This one is a Planck constant. If you then remember, will be good. Steven, if you're not, you can go to the table. Do I have a table here? Or I gave you the table. Right? You go to the table. That's constant. Now, let me tell you which table. Okay. I think I should have a table here. Go to here. Do I have a table? Oh, no. No, let me get the table. Okay. I think I sent you a table. Oh, here. The table. See? That's the table. Okay. H. If you can remember, will be great. If you can't, you look at the table. Everyone has this periodic table. If we do not have it, send me email. I will send you this afternoon. Okay. Right? Yeah, I will send it to you. Okay. You have two tables. Right. Two tables. Okay. Now let's go back. It's really cool. Chemistry, let me tell you, the most beautiful subject. I do chemistry since I was in the middle school. And do how many years? I never feel tired. Send me email. I will send it to you. Just send me email. Remind me. I will send the whole class table after class. Okay, I promise you. Now let's move on. We need to move on. Okay. Now next one we are going to learn atomic spectrum. Atomic spectrum. What's it mean? Atomic spectrum. So first we learn hydrogen atomic spectrum, and then we are going to expand. We call it atomic spectrum. Right? First one, we are going to learn hydrogen spectra. After we understand the hydrogen spectra, then we are going to expand atomic spectra. Do you think it's very easy to understand? Okay, let's do that. In terms of spectra, I want you to think about the rainbow. See, here is the rainbow. Look at it here. What's this? And that is a sunlight. That one is a sunlight. Also, sometimes we call it white light. When we use what? Use prism. I hope you learn a little bit in the middle school science. And that white light will separate to, sometimes people say 6 or 7 different colors. Right? That's the red, orange, yellow, green, blue, violet, indigo. See, you have 7 different colors. However, these 7 different colors from one color to another is very smooth. Very smooth. See, what's this? Look at the rainbow. You have different color. But from one color to another color, it's very smooth. See, you have a continuous range of the wavelengths and the frequency. That wavelength and the frequency is continuous. See, that is the wavelength, frequency. That continuous spectrum. Continuous spectrum, okay? What's it mean? Now, let me give you the picture, you understand. We are going to land down the road, but here I want to look at a little picture. I cannot wait. Oh, where we land? Oh, we land before. I forgot where we land. We landed. Where we land? Let me show you which page, okay? In the page 12. Page 12. See, this is two sides. That is continuous. See, it's a continuous. It's a white light. Continuous spectrum. Now, as we know, in the middle size, in this part, it's what? It's a quanta. See, this one is a continuous. I write a long time ago. That is a continuous. Now here is a quanta. Quanta is what? See, you can be here, 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 here. You cannot be here. The quanta here is the same. So, and stairs is quantized, but the change of the light height is continuous. Got it? Okay, now, so you make some connection. Make some connection. Okay, let's move on. Okay. It's really cool. It's really cool here. Go back, almost done here. So since the class is a little bit challenging, I want to slow down a little bit, okay? Right, see, it's a continuous, the wavelength and the frequency. Wavelength, frequency, look at it, continuous. It is continuous. And that's called a continuous spectra. Now, I'm going to look at hydrogen lamp. Have we learned hydrogen lamp? Yes, we did. Hydrogen lamp is that, so here is a hydrogen lamp, and it's the same way the light through the prism. And it gets light, it's not continuous. See, it's how many lights? 1, 2, 3, 4. And that 3, 4 lights is not continuous. Look at the wavelengths. 1, 410, another one 434, 486, 656. You got it, and that we called only a few discrete wavelengths, not continuous. What's that? And this one we called hydrogen spectrum. Hydrogen spectrum, it is what? It is a line spectrum. It is a line. How many? You have 4 lines. Not like white light. White light is continuous. Hydrogen spectrum, it is a line. It's a 4 line. And if we expand to other atoms, different elements, and that's called atomic emission spectrum. Okay, enough? Atomic, today we very young age, we learn atomic emission spectrum. In the regular time, you are going to learn this one, you should in the college. Atomic emission spectrum, such as, what's the color? What's the color? That one is a perfect yellow, right? Yellow is yellow. That comes from sodium. From the sodium atom. The sodium atom. You know, this yellow light everywhere, right? See, many times street, you have a sodium wave lamp. We have a intense, pure yellow-orange color. And after this section, you will understand, I understand why the sodium lamp will have a yellow color. But I want you to know is what? And that is what? Sodium emission spectra. That is a sodium emission spectra. Different atom, different elements have a different color. Okay. Now, before move on, I want you to see it. Okay, here what? Here's hydrogen. See, 1, 2, 3, 4. Now what's this? That's a sodium. See, Na sodium. Here's yellowish. It's pure yellowish. Now here it's no color. Here it's no color. It's no only have a yellow. Now what's this? Neon. There's so many colors. See, it's a beautiful color. See, there's so many colors. Okay. Now if you go to any downtown capital city, especially if we go to New York, you go to the New York, you have lots of evening and lots of beautiful lights, and most from neon. That's the color come from here. That belong to atomic line spectra. Okay, now look at the more. What's this? Here it's beautiful red. What's this is yellow? That's a sodium. That one is a sodium ion. What's this? That's a firework. It's a mixture of sodium, mixture of inorganic salts. Different color. Look at here. Like this year, 250 years. Lots of firework. Long time. Normally in our city, 50 minutes. And this time, 40 minutes. Lots of firework. Different color. And that, remember, next year, when you see firework, you tell your daddy, mommy, you said that is atomic emission spectra. Atomic emission spectra. Why? It's a different elements. So what's this? That's Sr2 plus. What's this? And that is a sodium plus. Here it's so many different ions, such as plus, such as Ba2 plus, such as cobalt 2 plus, such as zinc 2 plus. There's so many, such as sodium plus, such as Sr2 plus. There's so many salt mixed together. And we are going to give the energy. Okay? Got it. You get it beautiful. That belong to atomic emission spectra. Okay, go back. So what is atomic emission spectra? Atomic emission spectra of element, hydrogen, sodium, copper, zinc, lithium, potassium, sodium, a set of frequency, a set, not a continuous, a set of frequency of the electromagnetic radiation wave. Electromagnetic radiation, also we can say wave, emitted by the atom of that element. Remember, it is a set of a frequency. It is the electromagnetic radiation. That one comes from the atom of element. See, you have several individual lines. That line, each line is a different color, such as, so that's the color. What's the color? This is red. This one should be green or blue. This one is blue. It's a different color. There's 4 different colors, not continuous. I'm going to repeat. Atomic emission spectra. It is a line spectra. It is a line spectra. It is a set of frequency of electromagnetic radiation or wave. That wave will come from, that radiation come from where? Come from atom of the element. Okay, let's move on. Atomic emission spectrum is unique. Just like our DNA, just like our fingerprint. Because it's unique, we can use it to determine if element in the part of the unknown compound, such as give you unknown compound. Give you an unknown compound, then you are going to do called Fleming test. Fleming test will give us atomic emission spectrum, and you find yellow. Then it will tell us you have a sodium. You have a sodium, just like here. If you can, today, after the class, you can ask your daddy, mommy to help you do this experiment. Very easy to do that, but you are not going to do that, please. With the help of your daddy, mommy. Why? So what's this? This is the pickle. You know, pickle you can buy, right? You can buy a jar. Now, it's a 2 spoon. It's a 2 spoon. 2 spoon. Spoon is a metal. What's this? Then you put electrode. You put it connected to the power. You connect to the power. But that's why you are not going to do that. Now what will happen? You will provide electricity, right? Electricity, it is energy. And we are going to learn that the electron were excited. Electron will be excited to the high energy orbits. In the high energy orbits, electron not stable, going to return. Now they will release energy in the form of the light. So you will see the yellow color. Why? That's which it means you have lots of sodium chloride. You have lots of salt. You have lots of salt in the pickle. Yellow, there is a color. Running, that's it's a color. Yellow color. Oh, no. Not mean. And the street light is a pickle. No, street light, that one is a sodium. That's a sodium lamp, just like a hydrogen lamp. Got it. Not a pickle. Pickle, you have a sodium chloride, but street light, you have a sodium atom. Just like a hydrogen lamp, you have hydrogen molecule in the lamp. Got it. Yeah, I'm glad you come to this class. You learn some science. Okay, yeah, it is. It is. Okay. Yeah, so of course, this is the sodium lamp. I just said here it is what? That one is a sodium lamp. If your city evening light is yellow, that is a sodium lamp. Okay, it's a sodium lamp, yellow stuff. Okay, let's move on. Cool, huh? Yeah, I like it. I like it. You ask a question. Okay, now how are going to get atomic emission spectra? Use Fleming test. Some of you may did. Some that your school, middle school. Right? What's the emission spectrum? Emission is very easy. Use a platinum wire. Platinum wire. You dig it. You dig deep to the solution. Right? Deep to the solution. Okay. Sr2+. Oh, very good. Very good. Why use the palladium? Because when palladium, in that case, they will not emit the light in the visible. They will not. And that light will come from the metallic, another metallic ions. Okay? That's the reason. Now, then you insert the wire to the banner frame. Why? You give the energy, excited. So you will get red color. That's called Fleming test. You can do different compounds such as copper 1 chloride. We are going to name in the next chapter. That will give you the blue color. You can use lithium chloride, will give you violet color. If you have a sodium chloride, you will get a yellow color. Now potassium chloride, you get violet. Calcium chloride, you get red, white, green, light green, blue, light. Got it? Now, this one you need to remember. This one, it's not hard. You need to remember it. If I ask you, Steven, what's the Fleming test color of sodium chloride? What's the color, Steven? Yellow. Yellow. Good job. Good job. Good job. Right? Good job. Okay. Yeah. Yellow. Yeah. You can say like a banana is okay. Yellow. Right? You need to remember it. And every year, there's one question about atomic emission spectra. It is a color. Okay. Very good. Then move on. See, such as see, here is a red. Here is a yellow. Here is a mixture. Different colors. Now, what's this? Hydrogen. We have 4 different colors. Neon. Yellow. See, yellow is sodium. Right. Got it? Or why use a chloride? You can use a different salt. Right? You can use a different anion. We are going to learn it, such as you can use nitrate. Right. So such as, see, this one is what? Strontium nitrate. Yeah, it doesn't matter. Most is what is related to cation. The positive ion. Positive ions. Okay. Yeah. In terms, this is called an anion, right? Doesn't matter. But you need the soluble. Yeah, not all have the same color. No, you look at it, it's not. You have that color is unique. That color or unique. Okay. So we done this one. Can we move on? Any questions so far? Steven, right now we use machine to do that. Steven, use machine. Use machine to do that. Yeah, that's called atomic emission spectrum. Yeah, machine will do that. Okay. We are not going to do Fleming test. Fleming test you can do at the school, but very complicated. We use machine. Use machine to do that. Okay. We will learn more in the future. We will learn IR, infrared. We will learn NMR. We will learn mass spectra. We will learn UV and visible light. So we're going to learn more. Right. Now let's move on. Now listen. We discussed atomic spectra of atom, hydrogen. Hydrogen. So when it passes through glass prism, that will have emission spectrum. We call the line spectrum. You have how many? 1, 2, 3, 4. Now we are going to discuss why. Why we get this one. So we're going to learn Bohr model. So today I'm going to learn Bohr model, okay? And next week, this week, we are going to have a office hour, discuss homework, discuss the exams. Next week, next Sunday, we are going to have the first exam, chapter 3, and the most related word, quanta, wave property, magnetic radiation, particle property, and the Bohr model. Everyone learn chemistry from high school to the college. everyone to learn the Bohr model. Yeah, I'm going to discuss. We still have some time. Bohr model, okay? Bohr model. Where is the Bohr? It's a David Bohr. Bohr model won the Nobel Prize 1922. And the reason won the Nobel Prize because who is the first one proposed the model called the Bohr model and proposed the equation, mathematical equation called the Bohr equation, and use that equation to solve that equation, and the results match this line spectrum perfectly. Yeah, so that's the contribution. Can you believe it? That's the contribution. Who is the first one solve why hydrogen atomic spectra in the visible light? You have a 4-line Y, and use his equation and to solve one, match this exactly. That's this Bohr model. Now, Bohr model, I'm going to one by one, okay? Bohr model is based on two theories. One is called classical physicists. Classical physicists. And the Bohr model said, so hydrogen, how many protons? 1 proton. How many electrons? 1 electron, okay. 1 proton, 1 electron, okay. And Bohr used classical physicists and sun. I tell you, Earth and the sun, what's the relationship? Who is the center? Is the sun or is Earth? So Earth surrounding the sun. Nicole, agree with me? Right. Now, Bohr said electron surrounding to the nuclear. And that concept is from classical physicists. Just like Earth or plants are surrounding the sun. Easy to understand, huh? So that's the first theory. And the second one, that's the first one, classical physicists, okay? The second one use quanta. And who proposed quanta? Max Planck. And based on the quanta theory, electron can only be certain orbits. Electron can only be here, can only be here, can only be here, can only be here. That's the quanta, right? Did you remember? See, stairs. You can only be here, 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 here. You cannot be here, here, here. That's a quanta, okay? Electron can only be in the orbits. You cannot be here, 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 here. That's the second theory. What's this? Classical Higgs quanta. Next one. And they give orbits a name. So when closest to the nuclear, and that one called n equal 1. N can be 1 to affinity. When n equal 1, this is the ground state. Ground state. Oh, for the first time, we introduce ground state. Now, when n equal 2 to affinity, we call it excited state. Ground state only has one state. One, because n only has one module, one state. Now here, remember, I introduced called the state. You said, what's mean state? What's the mean state? To be honest, you tell me what's mean state, very hard to explain. But it just know when n equal 1, we call it ground state. And the ground state is only one state. Why? Because n can only one module. Excited state is affinity. Why? From 2 to affinity. That's the second point. Now we are going to very detail. The fourth point. Each state electron has energy. And that energy we call the Bohr model or Bohr equation. ENH equal minus 2178 times minus 18. Unit is a joule and Z square N square. What does it mean Z? Z is a nuclear charge. Nuclear charge basically is what? It is atomic number. Or number of proton. Right? So nuclear charge it's basically it's atomic number. Hydrogen, what's the atomic number? Atomic number equal 1. How many proton hydrogen? Only 1. That's called nuclear charge Z. For hydrogen, Z equal 1. For helium, Z equal 2. Now what's the N? N, it is integer. We said the orbital. N is integer, orbital. N can be not 0. It's 1, 2, 3, 4. Now, this equation you need to remember. Now, here, very important one is minus. In the minus plus, in the chemistry, in the physics, is very important class. Minus plus, very important, okay? How important? Because that will tell us energy, positive or negative. So energy minus, which means electron bound to the nuclear stronger. The more negative, which means electron bound to nuclear stronger. Energy lower when N equal 1. And that N equal what? E equal 2 minus 2.17 times minus 18 joule. That's the lowest energy possible. Now, N equal affinity. Can anyone tell me equal what? 0. Do the math. 1 divided affinity square equals 0. You do the math. So what's it mean? Which means I'm right here. So here is nuclear. If we are going to take away electron, that electron affinity, we set NHE here equals 0 when electron close to the nuclear and become more negative, energy lower until n equal 1, we set ground state. And E equal what? Equal minus 2178 times 10 to the minus 18 joule. Okay. Now, that's the fourth. 2 more, then we are done. Fifth, I'm still go to here. When electron from 1 to 2, when electron from n equal 1 to n equal 2, and that one, you have delta E, electron from low energy orbits go to higher energy orbits. That's a delta E. Delta E, or delta, what's mean delta? Mass. The change. The change of the energy. Always equal what? E final minus E initial. You know F final. Initial at the beginning. Tell me positive or negative. And that one should be positive. Agree with me? You can do the math. We're going to do that. Positive. And that one we call the absorbing energy. Requiring energy. Requiring energy. Okay. Now, next one, 6. Electron. From n equal 2 to n equal 1. Delta E equal E final E1 minus E2, positive or negative. And that one should be negative. Do the math. So that release energy. Release energy in the form of the light. Delta E, E2, E1 equal H nu, Hc lambda. We can calculate delta E. We can calculate lambda. Lambda equal what? Equal Hc divided delta E. We know H, Planck constant. E is speed of the light. Delta E, we know that. Then we can calculate. So that's why, see, experiments tell us atomic spectra of hydrogen, you have a 4 line in the visible light, and we can calculate based the Bohr equation. Where is the Bohr equation? This one. And it's beautiful math. Okay. So that's the highly summary about the Bohr model. Okay. We are going to do one by one discuss one more time, very detailed. Yeah. I want to stay here for a minute. You are going to make notes. Now, if you're still a little bit confused, I'm not going to worry, okay? I'm not going to worry. We are going to discuss one more time, okay? Okay, now let's go detail. Okay, Bohr model. Remember, huh? Bohr model. It will not like you can understand. You will understand. Okay. So the Bohr model is that come from two ideas. The first idea is a combined idea from classical physicists. If you think about classical physics, is what? And that one, it is related nuclear electron, just like the planets orbit the sun. That's a classical physicist, okay? That's the first one I'm going to write here. See, Bohr model hydrogen picture electron as orbiting the nucleus as the planet orbits the sun. That's the first one. The second one, they use new quantum theory. Just is a quanta. Did you remember quanta, Einstein, photon electron effect? See, energy can have only certain specific value. Energy is quantized. And based on you got the equation, Bohr equation, okay? En, okay, see? Right? Each state of hydrogen, n equal 1, we call the ground state, lowest energy state. See, n equal 1, ground state, energy lowest state. Okay, excited state, when electron gain energy, we said in an excited state, see, yellow, excited state all the way. Atom can have many excited states, basically as affinity. Basic affinity, okay? Right? Okay, that's the second part. Now go to next one. Go to next one. See? Planck and the concept quanta. Energy quantized. See, you can only be certain the value. Okay, go to next one. Electron in the hydrogen atom move around only certain allowed circular orbits. Classical physicists. The smaller orbits, the lower energy. Energy n equal 1, lowest possible. We call the ground state again. Now this equation you need to remember. Bohr equation. Bohr equation. This equation you remember, huh? En equal minus 2178 times 10 to the minus 18 joule Z squared divided n squared. N is an integer. Larger n, which means the orbital bigger. Go back. See, n equal 1 is this one. N equal 2, 3, 4, 5. Got it? Now go to move one. Go to next one. Look at the equation again. Z is a nuclear charge. Nuclear charge is the number of proton. It's atomic number. Look at the n, minus. Minus, which means electron bonded to the nuclear. It's lower. It's lower. So when electron at infinite distance, which means n is infinite, energy equals 0. That's a reference. That's a reference. See, the more negative energy, E, the more stable electron Y closer to the nuclei. Just like you stay home, always is safe. Are you with me? You stay home, always is safe. Why? With your daddy, mommy. Right, now go to next one. If we add energy to the electron, we can heat it. Fermi test. we can use light, photon. H nu, that's the light. We learned that. Electromagnetic radiation, light. Or we use high voltage. Basically, it's what? It's lamp, hydrogen lamp. We did it. Heat it, Raman test. Light, photon, instant photon electric effect, or high voltage lamp, hydrogen lamp, electron move to high energy orbits. That one can be from n equal 1 to 2, 3, 4, 5, or 2 can be 3, 4, 5, 3 can be 4, 5, 6, 4 can be 5, 6. Right? And we call it excited. N equal 1 ground, all this called excited. Now, when electron in the excited, they want to go back from high energy orbits to low energy orbits. They're going to emit photon. What's mean photon? Light. That's the light. So let's show you. I'm going to show you. See, what's this? Line spectra. Line spectra. See, 1. 1 is what? Basically, it's a 3 to 2. 3 to 2. Now this one, it is 4 to 1, 2, 3, 4. Yeah, 4 to 2. This one, it is a 5 to 2. That's color. So this one is a 6 to 2. You have 3 lines. So see, look at it. That's a 3 lines. You know, we can draw one more. So what's this? N equal 1, which means ground state. Now from 3 to 2, you get red. 4 to 2, you get green. 5 to 2, you get blue. Now, in a minute, we are going to calculate. Okay, we are going to calculate. We are going to calculate. It's really cool. It's really cool. Now, I give you a minute. Ask a question. Bohr model. We accomplished a lot today. Bohr model. Any question? Yeah, give a minute. G is a nuclear charge. Okay, nuclear charge is atomic number. It's the same thing. Why? Nuclear charge in the nuclear, there's a proton, neutron. Neutron, there's no charge. And the large charge only comes from proton. And the proton is atomic number. Got it? Right? Got it? Yeah. Now I'm repeat. Nuclear charge. Nuclear have a charge, is a positive charge. And that positive charge comes from proton because neutron no charge. And the number of a proton equal what? Atomic number, atomic ID. Right? Now, there's some confused about Bohr equation. Now we are going to discuss. Okay. Bohr equation, in this equation, there were 3 parts you need to remember. Okay, I'm going to erase it. 3 parts, okay? So the number 1, it is negative. It is negative. So it's negative. And the negative will tell us the more negative, the energy lower, electron more stable, electron more close to nuclear. The second one is G. G is a nuclear charge for hydrogen. G equal 1 for helium. Z equal 2. For lithium, Z equals 3. That's the second one. The third one, it is N. N is orbit. N could be equal 1. So we set a ground state. N could be 2, 3, and that we call the excited state. Right? And each N has NH. Okay, each N has NH. That's the equation. Now, how about this way? Let's do some practice. Let's do practice, and then you go home, review it. E is NH. E is NH. E. See, E-N-E-R-G-Y. We use E as NH all the time. Did you remember? E is NH. Okay. E, NH. Okay. Right. Got it. Okay, very good. What's the mean En? N is what? N is orbits, right? Which means each orbit have NH. Each orbit NH. Now, NH negative, which means, yeah, you get used to it. That's the first time we use negative, okay? You get used to it. Now, go to sample 1. Go to sample 1. I give you 4 minutes. You're going to do the math. 4 minutes, okay? Step by step. Now I'm going to teach you. You try your best, okay? Thank you. Good job. Good job. Thank you. I give you 1 more minute. Not a radio. We're not a radio. Okay, I'm going to do that. Okay. Cool, huh? Let's do that. Okay. The question said, calculate the energy required to excite it. So you need to give energy so that the electron from N equal 1 N equal 1 is a ground state. Ground state, it is NH lowest state. Go to N equal 1, N equal 2. N equal 2 is first excited state. First excited state. So the first one, calculate NH. We can do step by step. We said E N Bohr equation, right? 2178 times minus 18 z squared n squared joule. And this equation we just learned, the Bohr equation. Now n equal 1, E1, not the En, E1. Right? Equal what? Remember, hydrogen Z equal 1. So that equation equal minus 2178 times minus 18 1 n squared joule. Now, only hydrogen you use this one, not a nitrogen. That's the equation because hydrogen Z equal 1. So that n equal 1 equal what? 2178 times minus 18 joule. Right? Okay, any question this part before I move on? Any question? Yeah, when we have this part, any question before move on? Okay, now n equal 2. So which means E2 minus 2178 times minus 18, 1/4. Because 2 to the square equal 4. Got it. Equal 4. And you got what? You got minus 5.445 times minus 19 joule. Now, energy required, which means it's a delta E. Always it's E final minus E initial, step by step. E final is E2, initial is 1. So that it is minus 5445 times minus 19 minus 2178 times, hold on, minus 18. Minus is a plus. So that you get a plus equal 1.633 times minus 18 joule. Right? Now, why is the plus? Plus is required energy. See, here is the plus, it's required energy, and the minus is release energy. Now, that's the energy required when electron from n equal 1 to n equal 2. We finish this one. That's the first one. That's the energy. Any question? Any question, please? Okay, now next one. Also calculate the wavelength of the light must be absorbed by the hydrogen atom. Energy come from where? Come from the light. Come from electromagnetic radiation. So delta E equal Hc lambda. We did use this equation multiple times. Lambda equal Hc delta E. Now 6626 times 34 Joule. 2.9979 times 8 meter second. Oh, here's the second, sorry. Delta E 1.633 times 18 Joule. Now, second cancel. Joule cancel. You get what? You get the meter, which is the wavelength. Right? And that one equal what? Let me look at my notes. Oh, it's 1.216 times 10 minus 7. Now, if I convert it to the nanometer, what's the nanometer? That equal 1 to 6 nanometer, okay? Now tell me, what's this? That can I say ultraviolet? Can I? Yeah, so now I'm going to stay here for a couple minutes in case you have a question, okay? Yeah, 2 minutes. Then you can ask a question, okay? Now I will help you, okay? Now do that. Now, any more questions? I saw 2 questions asking me, okay? Yeah, have another 30 seconds, okay. Any more questions? Please, I see 2 questions. So what's the question said? Now I'm going to answer your question, okay? I'm going to help you, okay? The first question said, what's this number? And that number is a part of Bohr equation. Part of the Bohr equation. You need to remember, just like if we do the math, you have a sphere. The volume sphere equal what? Equal 4/3 pi r cube. Then you ask me, what's this for? 4/3 is a part of the equation to calculate the volume of the sphere. minus 2.178 times 10 to the minus 18 is part of the constant of the equation. Got it? Right. Now, the second one, the equation, the question is, how do you do this math? This math is, I don't know. On this, you never done math, to be honest. Right? That's the math. It's basically it's what? See, it is minus 5,445 times minus 19. You plus 2.78 times minus 18. What you are going to do? You can convert to the same power. Did you remember? You converted the same power. You can convert it to the minus 19 or you convert the minus 18 into the mass. Right? So that's the math. You will do that. You will do that. Okay. You see, please remember, you see this big number is what? Step by step, do the math. You can do that. I believe you. Okay. Right. Any question? Any more question? So in the future, we can use only combined equation, but right now I want you to do step by step. En n equal 1, n equal 2, delta E equal HC divided lambda. We do this one all the time. On this, you take a vacation, you just come home. You just come home. So you did not adjust it here. I have my homework list, right? So I do not want to call your name, right? Such as you said you know nothing, Mr. Xiao. Why? You last 3 weeks homework, you did not do that. Please catch up. You may just come back. This is the first class. Yeah, you need to do the work. We do this one many times, right? If you never do the work, you probably were behind, but you should be able to catch up. Okay. Right. Any more question, please? Okay, you have 5 more minutes. Let's finish this one. Try. Yeah, homework after the class. After the class, I will send it to the group. Now, try this one. Okay. Try this one. Okay. Yeah, try this one. Sample 2. Give you 3 minutes. You try it. Then we are going to discuss. Okay. 3 minutes. S. Haha. Very good. Very good. S is the name of the orbital. Okay. S is the name of the orbital. We are going to learn next class, which means n equal 2 go to n equal 1. That's mean. S, C, S, P, D, F, G. That's the orbital. Okay. Such as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Continue. We're going to learn that. Okay. S is the name of the orbital called the S orbital. Yeah, try it. See, we just discussed very detailed. The give me minutes, I will help you. But by the way, you did not do the homework in the last 3 weeks. You never touch your homework. I'm right? my homework sheet here. You did not do the homework. That's why you're behind the 3 weeks. Yeah, catch up. Catch up. I will help you. I will help you. Okay. You catch up, I will help you. You got it? Yeah. Very good. You wanted to catch up. You wanted to learn. That's great. But in the meantime, you needed to do the work, my friend. Okay, I'm going to do that. So this question, little bit challenge. Give me a couple more minutes, okay? Yeah, let's finish this one. And the question said hydrogen-like electron. It's not hydrogen, like a hydrogen. Hydrogen-like one electron. See, we know hydrogen. You have one proton, one electron. But it's not hydrogen. However, it is only has one electron. In this case, it's what? You are going to look at the helium. Helium plus, we learned that helium what? Z equal 2, atomic number equal 2. But you only have one electron. That's called a hydrogen-like atom, okay? Now, Bohr equation, En. Give me a couple more minutes, okay? Minus 2178 times minus 18. Z squared, N squared. But because it's a helium, Z equal 2. Z squared, 2 squared equal 4. Now equation change to minus 4 times minus 18 n squared. So that's the equation we are going to use. From n equal 2, which means here it's what? 1 over 4. So you get the 2178 times 18 joule. N equal 1. Here's 1. You get minus 4 times 2178 times minus 18 joule. So delta E equal E final minus E initial. So you get minus 4 2178 times minus 18 minus plus 2178 times minus 18. 4 minus 3 times 2178 times minus 18 joule. That's the delta E. Now, here it's negative, which means release energy. Now you calculate, you need to calculate the wavelengths. Wavelengths equal what? Equal HC delta E. Since E delta E is negative, we need to use absolute value. Right? We need to use absolute value. Otherwise, you get negative 6626 times 34, 219979 times 8. 3 minus 2178 times minus 18. Then you do the math. You do the math. You get 3.040 times minus 8 meter. You convert to the nanometer, 3040 nanometer. Can anyone tell me what's this? Wavelengths, I know wavelengths. What's the type of electromagnetic radiation, Steven? 30, ultraviolet. It is ultraviolet, that's right. It is ultraviolet, okay, UV. Now, class lesson. Class, today we discussed the Bohr model, and you will be fine. Do the homework, and you have questions, we will discuss, continue working on the office hour, okay? So office hour. Got it? Yeah. And I will see you on Sunday. Good night.
Good night. Thank you.
Bye now. Bye bye.
Good night.
Thank you. Good night.